The new dating star with Akbar. Dating with women, but not anymore. In this one, looks like a woman, but it's a guy. It's a trap. New dating show. What a guy.
It's the Justin Bieber Show. You guys are not gonna believe who I saw at the mall today.
Please tell us, Justin.
We interrupt this movie for an emergency broadcast.
Welcome back to Fitness Roadshow. Where fun never ends. And how never does visits.
So, in part 1, we're going to be talking about standard candles. Essentially, a standard candle is an astronomical object for which, because of the properties of the way it emits light, we know its magnitude without having to use parallax calculations.
Using n minus m equals 5 log d over 10, we can calculate distances much further away than what we usually could do.
Supernovae make for very good standard candles, and they can help us work out distances beyond 3.26 billion light years. There are two different types of supernovae, and the first is caused when a white dwarf collapses into a neutron star, causing an explosion.
This can cause an increase in magnitude of up to 22.5.
That's more than 1 billion times.
Because all type 1 explosions occur at the same critical mass, that means that they'll produce a very consistent light curve, with a very consistent peak intensity of about 19.3, as this graph shows. A type 2 supernova is about 2 orders of magnitude less massive. These result from the collapse of massive stars such as giants, as they violently shed their outer layers and collapse towards a neutron star or even a black hole. They show a very clear plateau in the way the graph goes down there.
And now, a message from our sponsors.
The Olympics is approaching fast, guys, so make sure you plan your journey.
Well, no crap. Well done, Charlotte. I just thought I wouldn't plan it, you know? Just thought I'd turn up. Just thought I'd see what happens. What the hell are you doing in this job? Get out. Welcome back to part 2. In this part, we're going to be looking at how supernovae affect a lot of other physics calculations, including ones about the size of the universe! The universe is big. In fact, the universe is expanding. But one of the important questions of physics is whether it's accelerating, decelerating, or staying at a constant rate of expansion. What we would expect, due to the effects of gravity, is that the universe would be slowing down from expansion. But looking at the brightness of type 1 supernovae, we can see that apparently it's accelerating. Now, the reason for this acceleration is unknown, which is why some scientists have hypothesized that it is in fact a form of dark energy. It's energy which we can't detect, but which is causing the acceleration of the universe's expansion. This could take up a very large percentage of what is in our universe. In fact, if we take a look at it, according to some experimental estimates, it's as much as 73% of the universe could be dark energy, with the rest of it being matter, but most of that is dark matter which doesn't give off radiation at all. Physics! Shut up! Welcome back to Physics Roadshow!
Using m minus n equals 5 log d over 10. Using m minus n equals 5. Using
So, a white star collapses into a... No, that's wrong. Repeat that. Wait. And the first type is caused when a white dwarf collapses into a...
That's more than 1 billion years. Time! The Olympics is coming up fast. Make sure you plan your journey.
Day 17 of my ordeal. I already want to shoot most of the rest of the cast. Supplies are running low, and I don't know if we're all going to make it out of here.